In this lesson, we will cover section 5.2, function notation. In this lesson, you will learn what is a function notation, express an equation of a linear function in two variables using function notation, how to express an equation in function notation as a linear function in two variables, and how to determine domain and range values from function notation. This type of notation may be new to you and a little unfamiliar. So function notation is notation used to show the independent variable in a function. For example, f of x means that the value of the function f depends on the value of the independent variable x. And your function notation will not always say f of x. It could be g of x, h of x, h of t. It depends on the situation that is given in the problem. H of t is a popular function notation when you're comparing height and time, where h of t would be the function of height, and your independent variable would be time t. So you need to think of a function as an input and output machine. Input can be any number in the domain, and the output depends on the input number. So the input is the independent variable, as can be seen there by x, and the output is a dependent variable. A function is a rule that takes an input value and gives a unique corresponding output value. So the input value will be the independent variable, whether it be x or t, whatever variable is shown in the bracket of the function. And the corresponding output value will be the dependent variable, which would be the function itself, f of x. The f of x notation is another way of representing the y value. So from here on out in several different chapters coming, the equation for a function may be represented by f of x. So you could have f of x equals 2x plus 1. Usually you would see it written as y equals 2x plus 1. But all that they're saying there is that that function is a representation of the x variable, and instead of saying the y equals, they're just going to make it a function notation. So for example, the notation f of 3 equals 7. This indicates that the point with coordinates 3 and 7 lies on the graph of f of x. So if you need to write the coordinate from the function notation that is written similar to what we have there, keep in mind that what is in the bracket is the independent variable, so that will always be your x coordinate. If you're going to graph it on the grid, you would have your horizontal axis, that will be your 3. And then you would move up to the positive 7 because that is your vertical axis, the y value, or the f of x value, the dependent. The letter inside the brackets indicates the independent variable used when the function is represented by an equation. So keep in mind that your number inside the bracket is your x value or independent, and what it equals to is the dependent variable. So let's look at an example. The equation C equals 5n plus the 500 represents the cost C in dollars for a gym rental where n is the number of people attending, and is asking to write the equation in function notation. So we're kind of familiar with these type of problems, similar from grade 9 with the linear functions or linear relations, where you were given a taxi question about how many kilometers someone traveled and the cost, or an amusement park, something similar to that. So we're going to look at the equation C equals 5n plus 500. What is the independent variable being used in that equation? Well, if we look at it, we're looking at the variable of n. For every person that attends, they have to pay $5. So we have to look at what independent variable is being used, and that's what you're going to use for your function notation. So C of n is the function now because the function C, which relates to cost, is being related to the independent variable of n. So whatever variable you have in your equation there, that's what you use for your independent variable, and you put in the brackets. And it's important to note that the function name is often related to the context of the problem. So In this case, they use C for cast, and like we mentioned earlier, if we have H, that will be for height. So it will always depend on the problem that is given and what function name it will have. So when we want to determine a domain or range value, you will determine the domain value of a linear function given the range value and vice versa. So let's look at the example. The function notation f of x equals 2x subtract 1. And this time we don't want to find the value of the function when using a domain value. We want to find the domain value when given a range value. So if we're given f of x equals 5, that means the whole function equals 5. So you will substitute that in for all of f of x, which will give us 5 equals 2x subtract 1. When we do this, we're just going to solve it like we do algebraically. You're going to add 1 on both sides, which gives us 6 equals 2x. Then from that point on, you're going to go 6 divided by 2 on both sides and 2x divided by 2. And the domain value that is produced with a range value of 5 would be 3. If we need to write that as a coordinate point, you would say 3 and 5 as the coordinate pair.